Hello everyone. This unit will deal with aldehydes and ketones. These are the two families of organic compounds which have been taken together because they have a common group which is present into their structure, which is C double bond O, and this C double bond O group is called as carbonyl group. The initial part of this chapter is the most important part, where we are going to learn the nomenclature and the structure of these two families. You are supposed to pay attention to the nomenclature part very seriously, because when we are progressing into this chapter at another level, then we are going to face certain problems. Like if I ask you what is the action of hydrogen gas on 2-methyl propanol, 2-methyl propanol. So this is an aldehyde, and we are supposed to write the chemical reaction for this particular compound. So if you know how to make the structure of this molecule, then only you will be able to solve the questions. So my request to you is you pay special attention to the nomenclature part so that you can master them properly, and you should be able to write the structures and names. Okay, so let us go to the definition part of this uh, chapter. Uh, the first part will be the definition, and then we will see the nomenclature. So aldehyde and ketones, these two terms are the name of the family of organic compounds. The member of these two families share one common organic functional group, which is known as carbonyl group, as I have told you, and aldehydes and ketones are also called as carbonyl compounds. So this is the similarity between them, that they are sharing a common functional group, that is C double bond O. So what is the difference between them? The difference is the presence of a hydrogen in aldehyde, which is not there in the case of ketones. Okay, so whenever you see and whenever you see a hydrogen on C double bond O, then that compound or that structure will belong to the aldehyde family. And when you see that C double bond O does not have any hydrogen on it, rather it is flanked by carbons on both the sides, then that compound will be belonging to which family? The ketone family. Okay, okay. So we are looking at now the nomenclature part. This is the first structure before us. What you see here is a C double bond O, and this C double bond O has a hydrogen on one side, which is basically fulfilling our requirement of considering it as an aldehyde. Okay, so this compound is commonly known as formaldehyde, and when you want to give the IUPAC name, what you will do is you count the number of carbons present in this molecule, and this molecule has only one carbon, so this one carbon will be considered as the parent methane from the parent methane, and we will call it as methane al. So what we are doing is we are taking the name of the parent hydrocarbon, and we are putting Al, which we are borrowing from the name aldehyde. Okay, so that is methanol. Now I am going to another molecule, CH3, C double bond OH. How many carbons you see here? Two carbons. So definitely you can come up with the name as ethanol for this compound as the IUPAC name. Commonly it is known as acetaldehyde. So acetaldehyde is the common name for this compound, and ethanol is the IUPAC name, where two carbons were counted, and we considered this compound to be coming from the parent ethane, and then this Al we have added because it has got this functional group C double bond OH. Okay, we are seeing some more examples here, and I hope that you will be able to now correlate the IUPAC name, that three carbons are there, 1, 2, 3, so that makes propane, and then Al we have here, so propanol, and commonly it is known as propionaldehyde. Similarly, when we go to this last molecule on the slide, 1, 2, 3, the longest chain what you get is the chain of three carbons, that is propane. So we are write propane and we are adding Al, so that makes it propanol. On the second carbon, what you see is a methyl branch. So that branch is also mentioned here, 2-methyl propanol. So that makes it the IUPAC name, 2-methyl propanol. Please pay attention that there are no spaces, no capital letters have been used in the IUPAC names. Everywhere we are using small letters and spaces are not there. Okay. When we are talking about the common name for this compound, what you see is that there are four carbons in a branch form. You can correlate these two structures together like this, and when there is a branching in the four carbon structure, you call it as isobutane, and from that isobutane word we are getting this common name isobutanoldehyde. We will see some more examples of aldehydes, and this one, if you start the count for the number of carbons, that will be 1, 2, 3, and 4. So what you get is total number of carbon in this molecule is 4. So definitely this is coming from butane, and on this C double bond O, because we have a hydrogen, so it must belong to which family? It must belong to aldehyde family. So accordingly we will call it as butanol. Okay, and commonly it is called as butyraldehyde. So this is how we are going to name them. You are again advised to pay attention how to give the names, and then you should be able to write the structure as well. We can at this moment what we can try is I will give you a name, you pause the video and you try to write the structure for the name which I am giving to you, and the name is 3-methyl 3-methyl butanol. So when we are getting this kind of name, what we are supposed to pay attention to is the last part of the name, that is butanol. This will tell us how many carbons are there in the chain. So this butane word is telling us how many carbons are there. How many carbons you have? 4 carbons you have. So what you will do is you will make a 4 carbon chain. Then you want to convert that chain into an aldehyde, because the name is telling you that you make an aldehyde, Al. So you will put a carbonyl and you will close the chain by a hydrogen. So that is the last part of the chain, C double bond O H. So that gives us a butanol chain. Then you put numbers starting from the functional group 1, 2, 3, 4, and then on the third carbon what you are going to put is a methyl. So that will be a CH3 group, right? And then what is the last part? The last part is you balance the hydrogens. So carbon number 4 requires 3 hydrogens in order to complete its 4 valencies, and carbon number 3 will require only 1 hydrogen to complete its 4 valencies. Carbon number 2 will require 2 more hydrogens. So that is how you can make the structure of 3-methyl butanol. Okay, I hope that you have understood how we are going to write the structures from the name, and I will now remove this structure, and we will go further to solve few more examples here. Okay, so we have another molecule, and this molecule, if you see, just try to give the name on your own and pause the video, try to give the name, and then again start the video, resume the video, and see whether you have done it correctly or not. Okay, unless you try it on your own, you won't be getting the nick of it, so better pause the video and put some efforts, please. Okay, I hope you have paused the video and now you have the structure on your notebooks. Let us go for the name. Starting from the functional group, I will count 1, 2, 3, 4, 4 carbon chain. So we have butanol, and on the second carbon you can see a methyl, so that would be 2-methyl butanol. So this compound is called as isovarylaldehyde, and it is common name, and the other name is 2-methyl butanol. A few more examples I am putting here. You please try to give the name by pausing the video and again check what you have written is correct or not. Okay, so I'm hoping that you are pausing the video and again resuming it. So probably what you did was you paused the video, you numbered it properly 1, 2, 3, and you might have noticed that on the second carbon there are 2 methyl branches. The longest chain is for how many carbons? 3 carbons. So that is propanol, and on the second carbon 2 methyls, so 2,2-dimethyl propanol. So 2,2-dimethyl propanol. That is the IUPAC name. Okay. It might be bothering your mind that whether you can remember all the common names for the examination. So my suggestion would be that up to the 4 carbon chain you can try to memorize the common name as well, and then if you are not able to recall these isovarylaldehyde or pavaldehyde, that is fine, that is totally fine. Okay, but you should be able to master the way in which we are writing the IUPAC names. Okay, one more example we have. It is a very simple one. I hope everyone will be able to write the name correctly, and when we are doing it systematically, starting numbering from the functional group side, which is the aldehyde functional group. So number 1 is given to that aldehyde carbon, and in total how many carbons are there? 5 carbons, so that makes it pentane, and then it is an aldehyde, so that would be pentanal. So this is the IUPAC name, and the common name is valeraldehyde. I hope that you are focusing and paying attention and trying to grasp everything to avoid future inconveniences. And let us have some more examples. In this example, I have introduced an aromatic ring. So this compound is known as benzaldehyde, or what you can do is uh, you can see that this is a carbon. So this carbon, which is only 1 in number, will give the name methane, and then it is an aldehyde, so it is becoming methanol as the parent name, and this part is taken as the branch, so that can also be called as phenyl methanol. Okay, and another example where we have a saturated side chain here, that is a doubly bonded side chain with an aldehyde functionality, and when you want to give it an IUPAC name, you will number the chain 1, 2, and 3. On the third carbon you can see a phenyl branch, and this is a 3 carbon chain, so it is propane, but it has a double bond as well, so it is propene, right? So what you are going to do is you will put on the third position, you are putting phenyl, 3 phenyl, and then 3 carbon chain stands for propane, so you are putting prop here, and then on the second carbon and third carbon you have a double bond, so you are mentioning the position of the double bond 2 in, so it is prop 2 in, and at the end, because it is an aldehyde, so you are putting Al, so that is 3-phenyl prop 2 enol. Okay, commonly it is known as cinemaldehyde. It is found in certain spices like cinnamon and that zira. You might be knowing zira, cumin. So it has got cinemaldehyde in certain proportions. So it is a phytochemical or natural product. Now we are moving towards the nomenclature of ketones. I have told you in the introductory part that ketones are the compounds which are also containing this carbonyl functionality. However, on both the sides, this carbonyl group is flanked by carbon. There is no hydrogen which is directly attached to this carbonyl. Okay, so now we will give the nomenclature to the ketone members, and we will see some examples here. The first compound is CH3, C double bond O, CH3. What you see here is a carbonyl group, and on both the sides it is attached to carbons, so this compound belongs to the ketone family. When we want to give it a common name, what we do is we mention these methyl groups in the name. There are two methyl groups, so we will say it is a dimethyl compound, and this compound belongs to the ketone family. So what I can say is that it is a dimethyl ketone, and that will be the name for this compound as a common name, dimethyl ketone. That is a ketone with two methyl groups. It is also known as acetone, and both the names are the common names and they are widely known. When we want to give the IUPAC name, what we are supposed to do? Basically, we are supposed to count the number of carbons in total present in the longest chain, and the number of carbons in this case are 1, 2, 3. There are 3 carbons. So it is a propane molecule. We consider it is derived from propane, the parent propane, and because it is containing ketone functionality, so now we will change that name propane into propanone, and this last "one" suffix is obtained from the family name, that is the ketone family name. So the name of this molecule is propanone. Okay. Now at this stage, if I ask you to make butanone, what you will do? So let us have some practice of a simple molecule, butanone. So what you will do is that you will pay attention to the name. It has got two parts. This is telling us how many carbons we have, number of carbons, and this part is telling us what is the functional group, what is the family of the compound, right? So butanone word is telling us that it is a ketone of 4 carbons, ketone of 4 carbons. So what I will do is I will put a chain of 4 carbons, and then I want to put a ketonic functionality. A ketonic functionality means that I should be able to put a C double bond O. So I am supposed to convert one of the carbons of this 4 carbon chain into C double bond O. Okay, but when I want to do it, what I will do is I will ignore the first carbon. I will not put a C double bond O there, because then I have to balance the valencies, and right now there are 3 bonds, so the fourth valency will be satisfied by hydrogen, and once I put hydrogen, this will not remain ketone, this will become aldehyde, right? An aldehyde. So what you will do is you will make 4 carbon chain, but you won't put C double bond O, or you will not convert first carbon into C double bond O. We'll put at some other place. So here what I'm doing is C double bond O. And then what you see is that this carbonyl is flanked by carbons on both the sides, so this must be a ketone, right? And now I am going to put hydrogens, so that would be CH3, this will be CH2, and this will be CH3. So everywhere I am ensuring that carbon is making 4 bonds. With the help of hydrogens, I am satisfying those valencies. So this is how we will be able to make butanone. So this molecule which is right now on the slide before you is a butanone molecule. Okay. At this point we can discuss the common name also. So what you see here is one side you have a ethyl group and ethyl group, right? Because it is a group of 2 carbons, and this group is a methyl group. So what we can do is we can mention these 2 groups in the name and put the word ketone at the end. So I will say ethyl, methyl, ketone, and that will give us the common name for this compound. So this compound is butanone, or commonly it can be called as ethyl methyl ketone. So I hope that you have now understood how we are getting ketones. So I will clear the space and we will see some more examples now. So the screen getting cleared for few more examples to come. Let us have another example, and this is nothing but the molecule which we have discussed right now. You made the structure for this, right? So ethyl methyl ketone is the common name for this compound, and it is also known as butanone. Fine. Now I can have another molecule on the screen, and let us try to give it a name. First we will give it a common name. What you see that on one side of carbonyl we have CH2, CH3 on one side. On the other side of C double bond O, again we have CH2, CH3. So these are the 2 ethyl groups. So the ketone can be called as diethyl ketone. A ketone with 2 ethyl groups is diethyl ketone. So you can see that even the common name is not so difficult for this family, diethyl ketone. And when you want to give IUPAC name, what you will do? You will number the carbons in the chain and count the longest chain of carbons: 1, 2, 3, 4, and 5. So what you see here is a chain of 5 carbons. So it is giving us the parent pentane, but I will convert it into ketone name, so it is pentanone. And additionally what I will do is I will mention the position of this ketone, that is the third position is the ketone position. So I will call this molecule as pentane 3-one. So pentane is for 5 carbons which are present in the chain. 3 is the position of C double bond O. So 3 is the position of the ketonic group or carbonyl group. In this case, pentane 3-one is the IUPAC name. Okay. Why numbering is important? Because we have another molecule with 5 carbons again. So we have another pentanone. But in this case, what you see is that the second carbon has the carbonyl. So you can see that these 2 molecules are having same number of carbons in their chain. So both of them are pentanone. But in the first example, it is having a carbonyl on the third position, and here it is containing the carbonyl on the second position. But both have got same number of carbons. So they are basically isomers of each other, and if you analyze them, there is a difference in the position of the functional group. So they belong to the class of position isomers. So when we want to give the IUPAC name, this molecule will be called as pentane 2-one. Okay. And let us give the common name as well. On one side we have a methyl, on the other side we have normal propyl and propyl group. So the common name becomes methyl and propyl ketone. Methyl and propyl ketone. So both the groups are mentioned here along with the name of the family. So every time the complete name of the family is getting repeated in the common name, methyl and propyl ketone, and the IUPAC name, as we have discussed, that second position is containing the carbonyl this time. So this is pentane 2-on. So I hope now you realize the significance of numbering the chain, and also important part is that you pay attention to is that while numbering I ensured that the functional group is getting the lower number, right? So I gave numbering to the last molecule from the right hand side, because if I am numbering from this side, second is the number I am getting. If I am getting from the left hand side numbering, then 1 2 3 4, fourth will be the position of the carbonyl. So what we do, we prefer the side which is near to the functionality, which is giving lesser number to the functionality. So we are choosing this side to number, and from this side we start numbering. Okay, few more examples we can have. So here we have certain structures where what you can do is definitely analyze in terms of the branches which are present. So here one carbon branch is there, so you know that this is a methyl group which is present, right? And if I analyze this structure, this will be CH3, and this will be CH, and this will be CH3. So this fragment or this group is nothing but isopropyl, right? Isopropyl, and this group is methyl. So when I want to give it a the common name, I will mention them, and I will take care of the alphabetical order. So methyl comes first in alphabetical order, and P comes later. M comes first and P comes later. So accordingly I call this molecule as methyl isopropyl ketone. Okay, so that gives us the common name, methyl isopropyl ketone. While giving it the IUPAC name, what you will do is you will number the chain to find the longest chain of carbons containing the functional group. So this is the first carbon, second carbon, third carbon, and the fourth carbon. This is the longest chain of carbon, that is 4 carbon chain, and this chain is also containing the functional group. So that is how I found out or identified the longest chain. And now on the third position what you see is a methyl. So what you will do is mention the longest chain as the parent, butane, right? And on the second carbon it is 2-on, so butane 2-on, and third carbon has a methyl. So the branch is mentioned first, 3-methyl. I hope you can connect properly. What we are doing here is mentioning the branch first, right? So 3-methyl, and then butane is the parent, and on this parent chain a ketonic group is present at the second carbon, so it is 2-on. So 3-methyl butane 2-on. So this is how we are getting the IUPAC name for this molecule. Okay, one more example. You try to pause the video and then try to give the name, and again resume the video and check what you have done is correct or not. Okay. Okay, hope you did the same, and now you have the structures ready on your notebook. And while giving the IUPAC name, I will find the longest chain of carbon in this fashion: 1, 2, 3, 4, and 5. I hope that you also identified this chain properly. 1, 2, 3, 4, 5. 5 carbon chain is pentane, and on the second carbon of this longest chain we have a ketonic group. So this should be pentane 2-on, right? Pentane 2-on. And the third carbon is bearing what? A methyl group. Third carbon is bearing a methyl group. So that will be mentioned as 3-methyl pentane 2-on. Okay. 3-methyl pentane 2-on. And the common name will be, well, this is the 3-methyl pentane 2-on.
What about the common name? I will tell you how we have got this common name. I will just clear up the structure and see how we have got this one. So what we do, we mention both the branches. So this on one side we have a methyl branch or a methyl groups, and the other side we have a fragment of how many carbons? 4 carbons. You can see 1, 2, 3, 4. Right. I hope you can identify the secondary carbon also here. Though this 4 carbon fragment is attached to the functional group, that is C double bond O. It is attached to the functional group from its secondary carbon. So that is why this word is used here, abbreviation secondary butyl. So this is the name of the group, secondary butyl on the left hand side and methyl on the right hand side. Secondary butyl methyl ketone. So that is how we get this common name for the molecule, secondary butyl methyl ketone. Okay, now we have another example, and in this example what you see is again the longest chain is for how many carbons? 5 carbons. 1, 2, 3, 4, 5. Now what I suggest is that you pause the video at this stage and again try to give the name, that is the IUPAC name. Okay, I hope you have done that, and what you have got is uh, on the second carbon we have a methyl, on the 4 carbon we have another methyl, so that will be 2,4 dimethyl, isn't it? 2,4 dimethyl, and parent is containing how many carbons? 5 carbons, so that is pentane. And on the third carbon we have one, so that will be 2,4 dimethyl pentane 3-one. That will be the IUPAC name. We will verify it after giving the common name also. So while giving the common name, what you can do is you can see that the molecule is symmetrical. On both the sides we have same type of functionalities. So this is the CH3 group, this is the CH group, and this is the CH3. So this group is isopropyl, and of course then this group is also isopropyl. So you will get di-isopropyl ketone as the common name, and 2,4-dimethyl pentane 3-one is the IUPAC name, which probably you have given it on your own as per my suggestion. Okay, so this is how we are giving the common names and IUPAC names to these compounds.
We will see some more examples. This time we have a molecule in which we also have one aromatic ring. This is the ring which is containing 6 carbons, right? And total number of hydrogens present on this ring are only 5. So this is a C6H5 ring, C6H5. This is normally called as phenyl group, right? So this is a phenyl group which is present on the molecule. On this side you already know which group is present, that is a methyl. So phenyl methyl. So this is a ketone which is containing methyl and phenyl functionalities. So what will be the name? In alphabetical order, when you are mentioning, the name will be methyl phenyl ketone. The other name for this molecule is acetophenone. So these are the two common name for these compounds: methyl phenyl ketone, acetophenone. When we are giving them the IUPAC names, we always count what? The number of carbons in the longest chain to get the parent. So in this particular case, we have only 2 carbons, right, in the longest chain of this molecule, because the other thing is not a chain, it is a ring. So this thing is a ring, not a chain. So this chain will be used to give the IUPAC nomenclature. So you are supposed to number the chain, and how you are going to number it is starting from the functionality itself, first and second. So 2 carbons are there in the longest chain, so it is the chain obtained from ethane, and as per the functional group it is ethanone, right? Ketonic group, ethane. From ethane we are making ethanone, and on the first carbon itself we have a group which is already known to us, phenyl. Yes, phenyl. So we will call it as 1-phenyl ethanone. Why 1? Because 1 is the position, that is on the carbon number 1 we have this functionality, this group phenyl present, so 1-phenyl, and 2 carbon ketone is ethanone. Let us look at another example. What we see here is two aromatic systems which are present, and we know that you can call it as diphenyl ketone, because both the groups are phenyl groups. So you can call it as diphenyl ketone, or it is also known as benzophenone or diphenyl ketone. So both the names are acceptable, benzophenone and diphenyl ketone. What about the IUPAC name? The longest chain of carbon. So only one carbon in the chain in this case, right? And that too, that carbon itself is the carbonyl group. So you know that the parent of one carbon is methane. So this is a methanone compound, methanone. And on both the sides, you have got these branches, phenyl branches. So you can call it as diphenyl methanone, 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 diphenyl methanone. So this is how we give the IUPAC name to this particular compound, which has only one carbon as its parent. Okay. Now we have another example where we have, yes, how many carbons in the longest chain? Count from carbonyl. Yeah, always count from carbonyl in this case. Uh, one, because it is aromatic system on one side, so you are supposed to count from carbonyl. 1, 2, 3. So 3 carbon chain is there. So it is propanone. On the second carbon we have a methyl. On the first carbon we have a phenyl. Right? Yeah. So what will be the name? The name will be 2-methyl. Second carbon pair we have methyls, 2-methyl, 1-phenyl. On the first carbon we have phenyl, 2-methyl, 1-phenyl, propane, 1-one. So that C double bond O is also present on the first carbon. So you mentioned that also, the position of that C double bond O. So it is also 1. So 1-one. 2-methyl, 1-phenyl, propane, 1-one. Okay, when we are looking at the common name, what we will do? We will see that on the C double bond O, we have two groups which are attached. One group is phenyl group, and now this group you must be able to recall by this time because we have seen it 2, 3, 4 more times. So this is isopropyl, right? So this is isopropyl group, this is phenyl, so accordingly the name becomes isopropyl phenyl ketone. So these are the nomenclatures for aldehydes and ketones, and I am hoping that you will listen to each and every slide carefully and see each and every example properly, and you will do the writing practice along with this discussion so that you can get maximum benefit out of it, and you will get confidence that you are able to write the structures, you are able to give the names. So please see the slides carefully and do enough practice so that you have enough confidence to face these kind of questions. And these questions, this part is not only useful for uh, 1 mark question like make the structure or write the name, because we have problems like what is the action of hydrogen on isobutylaldehyde, what is the action of hydrogen on methyl phenyl ketone, or what is the action of methyl magnesium bromide on benzophenone. So when these kind of questions are coming before you in the examination, you should be able to write the structures. Unless you write the structure, you won't be able to complete the chemical equations. So I hope that you realize the importance and significance of this part of discussions, and you will try to get enough practice.